Imagine everything humanity has made, compressed into something no larger than a coin. Not for years, not for centuries, but for billions of years, long after we are gone. This idea is no longer fiction. It's real. The Superman memory crystal. Today we trust hard drives, SSDs, disks, and the cloud, but they're all temporary. Formats rot, drives fail, servers shut down, digital memory is fragile. And the cloud needs electricity and constant upkeep. We create over 120 zettabytes a year, an ocean of data swelling every day. 1 zettabyte is a trillion gigabytes, an almost incomprehensible scale. Our current systems are drowning under this tidal wave. Researchers at the University of Southampton chose a different path. They write data with pulses of light inside fused quartz, not on the surface but through its volume. They call it 5D storage, because data lives in 5 variables. 3 spatial dimensions, width, height, and depth, plus 2 optical dimensions, polarization and intensity of the light. These give many more states per spot. Extreme density. A single crystal can hold around 360 terabytes, roughly 7,000 Blu-rays. That's tens of millions of photos or entire libraries in your pocket. Capacity that once belonged to warehouses now fits in a palm. Made of fused quartz, the crystal endures heat up to 1,000 degrees Celsius without data loss, resistant to water, scratches, and even radiation. Where other media would be destroyed, the crystal survives. Laboratory extrapolations suggest data could survive billions of years at room temperature, a number that matches the age of the universe itself, from fragile papyrus to near-immortal glass, a leap in permanence. The nickname Superman crystal nods to fiction, Krypton's glass archives. Now science has echoed that imagination with real, durable archives. The arc from myth to lab is striking. Our oldest written records are millennia old, many histories already lost. Each format change erases swaths of cultural memory. What if we could stop that cycle? Governments could lock away constitutions, laws, and records permanently. Scientists could preserve centuries of research without format migration. NASA could send these crystals on interstellar trips as seeds of knowledge. Personal legacies, photos, stories could outlast civilizations. Museums could create permanent catalogs of human culture, a compact archive for everything we deem important. But it's not plug and play. Writing needs femtosecond lasers. Reading requires specialized microscopes to decode nanostructures. Right now, the process is slow and expensive, a lab technology. Every tech starts in labs before scaling. CDs, SSDs, and more. With investment, costs fall, consumer access follows. Expect 10-20 years for broad use. That timeline could shrink with breakthroughs and demand. Other long-term ideas exist. DNA storage packs immense density but has its own challenges. Holographic storage aimed for high density but faces stability and cost barriers. Each approach trades density, durability, and accessibility differently. Powerful as it is, the technology raises risks and questions. Who decides what is preserved? Could permanent archives be abused? Curation becomes an ethical act, not just a technical one. We must ask, what matters? Every tweet or the ideas that shaped us? Memory is about meaning, not just bytes. Perhaps we prioritize wisdom, discovery, and culture. Imagine a Library of Alexandria that cannot burn, a cultural memory that survives wars, climate, and time, a human story preserved for generations, or eons. If we leave Earth, crystals could carry our knowledge across space, silent seeds of civilization, drifting through cosmic time, a trace that might outlast its makers, a practical pipeline, digitize, curate, write with lasers, and store in secure vaults. Metadata, documentation, and error checking remain essential for future readability. The act of preservation is both technical and legal. Open standards and documentation are needed so future readers can decode the data. International cooperation will determine who reads our story. We should leave instructions as part of the archive. Cost today is high, but economies of scale and engineering can reduce it. Mass production and standardization are the pathway to accessibility. Then, entire nations' archives could fit on a shelf, not a campus of servers. Best case, a distributed, resilient human memory spanning epochs. Worst case, centralized control, curated narratives, or exclusion. The shape of this future depends on choices we make today. If we can make memory eternal, we must decide what memory deserves permanence. Inclusion, representation, and scientific record-keeping must guide us. Preserve wisdom, not just noise. This technology reframes what legacy means, not monuments, but ideas and stories. What we choose to leave becomes the voice that speaks for us, a tiny object carrying a vast human voice. Learn the science, advocate for open archives, and curate what matters. Support public projects, fund research, and demand accessible standards. Make preservation a civic project, not a private monopoly. Superman crystals, vast capacity, almost unimaginable durability. Real engineering challenges: capacity, durability, and responsibility. A new medium for the oldest human desire, to be remembered. If you could place one thing into an immortal crystal, would you send your life story, our greatest discoveries, or a message to the unknown? The choice defines our legacy. What will we choose to leave behind?